Okay, welcome to this tutorial session. We're going to look at some basic integration. So I've got 5 questions which we are going to focus on today. I don't have to waste much of the time. Let's dive in. So determine the following. A, looking at the integral of 1 plus x squared, we divide by root of x and with respect to x. So how do we integrate this? Step 1, expand. So after expanding, you should be able to get 1 plus 2x plus, well, x squared, like that, over root of x, then dx, right? After expand, then this is a common denominator, so it can go through everything there. So I'll write from here. So we're having 1 over, now root of x, you must be able to remember from mathematics secondary that root of a is just a to the power half. So here we are going to have x power half, okay, plus 2x power x, like that, plus x squared over over x power half, everything with respect to x. Now that we are there, we can now, when we reciprocate this, we end up having x negative 1, 2. And when we reciprocate this, remember, same bases, we add the powers. So 2 is constant. So the x, the power on x there is 1. The power on x is 1. Because we are dividing, we subtract the powers. Plus, same here, x, 2 minus 1 over 2. Just like that. Then everything, dx. We're moving on. So we have the integral of, we have to simplify this further. We get x negative 1 over 2 plus 2. What is 1 minus half? You get half, plus what is 1? So 2 minus half, you get 3 over 2, right? So you get x to the power 3 over 2. Now we have reached at a stage where we can easily integrate. So integrating this, it just means we increase the power by 1, then we drop the same power as a divisor. So we end up having x. If I increase this one by 1, I'll get half. I'll divide by half. Plus, same thing applies. I'll increase this one by half, which will give me 3 over 2. Okay, I will divide by the same 3 over 2. All right, plus if I increase this one by 1, I'll get 5 over 2. This will be x 5 over 2. I will divide by the same 5 over 2. Okay, after doing that, this just gives me 2x power half if you evaluate the fraction, and this one will give me 4x 3 over 2. Or these two multiply that 2, plus I'll get 2x power 5 over 2 and over 5, like that, plus c. It's fine, you can leave it like that. Well, if you know what you are doing, and I repeat myself, if you know what you are doing, you can further say power half is just root of x, plus this is just the square root of x to the power 3. So we get 4 over 3 multiplied by x power 3. Plus, here we have 2 over 5. Same thing here, all right? It will be the square root of x power 5 plus c. You can do it like that. You are still doing the correct thing. That is if you know what you are doing. But I will encourage you to leave it in the way it was as before, because in the beginning, it had roots. All right, so we are done for this one. Now we move on to the next one. The next one is b, which is the integral of 4 cos 3x dx. All right, so that, how do we integrate that one? All right, so we need to know the integral of trigonometric what? Functions. All right. So 4 is constant, so we can take it out. This just means that you have 4 integral of cosine of 3x with respect to what? To x. And what happens when you integrate cosine actually? Well, you get sine. But remember that we always divide by something in integration. So we get 4. So this part here, which is here, let me do it slowly by slowly. And from now on, you should be able to do it direct. All right. What we're going to do is this. You let u be equal to this 3x. Then find du dx to give you 3. So make dx the subject of the formula, which will give you du over 3. Because you need this dx. Therefore, then you go back. This is 4. The integral of this becomes cos u. Now we need to replace dx with the du over 3. So 1 over 3 can come out and join 4. This will be 4 over 3. And the integral of cos what? U du. Now, what's the integral of cos or cosine? The integral of cosine is just what? Is sine u. And we can now end the solution with this. What is u? In the beginning, u was what? 3x. So plus c. Done. If you know what you are doing, you don't have to do this. I'm doing this because I'm tutoring you. But as long as there's an argument here, just differentiate that, then divide it. That's all. So we are done with that one. Next is C, which is the integral of 7 sec squared 4x dx. Again, 7 is a constant. Take it out. Okay, like that. And recall, if you know the table of integrals, all right, again here I'm going to say let u be equal to 4x. Then we can say du dx is equal to 4. Then we make dx the subject of the formula to give us du over 4. Then we go back to our integral. This becomes sec squared du over 4. All right, so we can take out the 1 over 4 out, which gives us 7 over 4, and the integral of sec squared du. Oh, sorry, there is u here. U du. Now, recall that the integral of sec squared, let's say theta, the theta is just tangent theta. All right, if you are able to remember this, you are well and dry. All right, so we get 7 over 4. So the integral of this gives us what? Tan what? Tan u plus c, which will give us 7 over 4 tan. What was u? Tan u was 4x, so we put 4x there plus what? C. Just like that. We ought to go, ladies and gentlemen. We move to the next one, which is D. Okay. D is the integral of 5 e to the power 3x dx. All right, so how do we deal with this one here? Okay, so 5 is constant. Take it out. Remains e power 3x dx. What you do is that you are going to say let u be equal to 3x. All right, then you define du with respect to x. This will give you 3. Then what is dx? Dx is just du over 3. So as we substitute there, we are substituting e to the power u. Then you have dx with what? Du over 3. You can see that 1 over 3 is common. Sorry, it's not common. Just take it out. You get 5 over 3, the integral of e to the power u, and du. Take note, the integral of e to the power x dx is just the e to the power x itself. There's nothing complicated about that. So you get that? So integral of e to the power u is just e to the power u plus c. But we know what u is. U is actually 3x. So this will take us to 5 over 3. We get e, 3x there plus c. Just like that. Okay? Simple as that. Next question is e. Question e, which is the integral of 2 over 3e power 4 like that. Take note, 2 and 3 are constant, so you can take it out. So 2 over 3, take it out. We remain into 1 over e power 4t dt. But we can reciprocate this. If you recall from your basic mathematics, this is just the inverse of negative something. So we get 2 over 3, the integral of, once I take it up, this becomes e to the power negative 4t dt. Let u be equal to negative 40. Then you can find du dt as negative 4. Then dt, okay, what will be your dt? Your 2 will be equal to du over 4, but with a negative there. Then we can now go back and say we have 2 over 3, the integral of, this becomes e to the power u, then negative du over 4. So we can take that one out. So we get 2 over 3. Negative 1 over 4 can come out. Negative 1 over 4 can come out. Then integral of u like that. And like that. We're almost there. 2 there 1, 2 there 2. So we get negative 1 over 6. 2 and 3 can multiply. So now we integrate this one, we still get e to the power u plus c. And we know we are getting negative 1 over 6. This is e. What is u? U is negative 4t. Is negative 4t plus c. Now we need to take it back the way it was, just like the way the question is a denominator there. So we end up having 1, okay, over 6 e to the power 4t like that, okay, then plus c, but there's a negative there. That becomes the final answer. Thank you so much. Please subscribe and follow for more. Okay.